So hi everybody, this is Bill Bittner. Today is Monday, January 27th, 2020. And what we're going to be covering today are ZVM CP system services. When Alan Allmark talked about the 12 pillars, two of them that he talked about was one, performance management, which has a number of sub-disciplines underneath it. Capacity planning, what I call traditional performance management, problem determination are all part of that. And then another pillar he talked about was chargeback, right? And he kind of talked about that as perhaps one of the only optional pillars. But it is one of those things that I think regardless of whether you actually do a chargeback, you should think about it, right? And think about the idea of what is the cost of computing on the platform. And so we'll do a week just on chargeback alone and potentially multiple weeks on performance itself. But as I thought about that, I realized that where the data comes from for those disciplines is important, or having a background on how some of that works. And what that lended itself to was me thinking about the system services in ZVM. Some of you know Neil Ferguson from C&A Nominee Associates. So he has sometimes described ZVM as an intelligent or programmable BIOS. So this idea that you can actually interact with what's running the system. And so in a sense that's what ZVM as a hypervisor is. And so these system services are things that allow you to interact with the operating system. So the majority of them are documented in the CP Programming Services Manual. A little trivia question, well, which one is not? That would be Star Monitor. For various reasons, we moved that into the performance book back in the 90s, right? It's actually in an appendix there. Now, these days, it's kind of rare for what I would call system programmers or end users to really have to code to those system services. But I think it's important for people to understand that they're there and what their purposes are, and that they add this level of capability and flexibility to the system. There's multiple ways that you can interact with the operating system, the hypervisor. The Programming Services book will talk about some others, right? Now, two of the things we've mentioned briefly in here in the past have been IUCV and APPC VM, right? So IUCV is Inter-User Communication Vehicle, and kind of think of it as sort of a sockets-like protocol. Right, and we'll talk a little bit more about that later on. That's actually what we're going to use to connect to these system services. APPC VM is another protocol that came after IUCV. It was a more extendable protocol. It's used across multiple platforms, or was used across multiple platforms. It's also related to SNA, or some people would call it just SNA. So those of you that may remember VTAM and those type of protocols, it's in that space. Again, that's maybe something for another session that we cover. Along with the system services, there's also a whole set of diagnose instructions. The diagnose instruction is an actual instruction in the architecture. It was originally designed to allow information from the hardware to be returned to operating systems, but ZVM has virtualized that, right? And so there are some diagnoses that can be issued when you're in an LPAR, or that kind of environment, so when you're running directly in a partition. And then there's diagnoses that can be issued when you're running in a virtual machine, right? And there's some diagnoses, these would be good trivia questions, that you can issue in both scenarios, right? There's some diagnoses that we use to interact with spin locks in the system, whether it be with inside ZVM or with inside guess, such as diagnose 44 and 9 Charlie. Those can be issued either to LPAR or to ZVM. They behave similarly, but just a different context. So those are also important ways that we interact with the hypervisor. All right, and as I said, that you typically won't have to code these up, but you should be aware of different applications and so forth that use them. Also, I sometimes use this as a trick when I'm talking to people that are explaining their products. If they can't tell me what system services they're using, they're probably not the technical person, right? They're the marketing person, right? Okay. So as I said, these are socket-like interfaces. You can connect, you accept connections, you do sends, you do receives. Now, depending on what system service we're talking about, you may not send data to CP, right? There may be somewhere you're just receiving data. And you'll see later on that the star monitor is really special. It kind of behaves a little bit differently from this. Right? Now, IUCV, you'll typically see references to that in communication between different virtual machines. However, in this case, we're really going to focus on it talking to the hypervisor. You'd also see it at times, environments or applications where I have a server virtual machine, right, and I'm going to send requests to it, right? The same is similar for APPC VM. Now, you do need to be authorized for this, so I won't go into details here, but you do need in the user directory statement the permission to be allowed or authorized to connect to these system services. Because in some cases, you are getting data that perhaps the general user should have access to, right? In particular with some of the monitor information and some of the security information. And in some cases, you're going to find some other special requirements that we'll cover or mention briefly here. Okay, so what are these system services? There's a whole bunch, and I wanted to mention all of them very briefly, but we'll really focus on two of them. So Star Account is one of them that we're going to talk about, and really is where accounting records get generated from. There's another system service called Asynchronous CP Command Response Service, right? And so for some of our commands where we don't want to be serialized by those commands, right? So some commands that don't have an asynchronous option, right? And we don't want to have to sit there waiting for the response, because in some cases we might not be able to react if something went wrong. There's an interface to be able to deal with that separately. I haven't used it myself, but that's there. Some different products that do some things with CP from a systems management perspective will leverage that. Star Block IO, for those of you that are familiar with doing IO in a CMS environment, while we do support Start IO and Start Subchannel, right? So remember our heritage here that CMS beckons back to the days of 360 and 370. So pre-XA, pre the architecture changes, particularly that were significant in IO. So we used to have Start IO instructions, which were later replaced with Start Subchannel. Typically, the way we would do disk IO in a CMS environment was with diagnosis. So Able 4, Able 8, I believe, are two of the common ones that we would do IO with. And that was a nice way of having to hide some of the device-specific requirements from the guest and letting CP, the hypervisor, worry about that. Now, while that was a very effective way of doing IO, it wasn't always the most efficient, particularly when we started dealing with more and more data, right? And so Star Block IO was invented to help deal with that, which allowed applications, typically server virtual machines, to do block IO. So to do multiple blocks of IO through this interface, and again, letting CP worry about it, right? So the CCWs, or if we're talking about high performance FICON today, the transport mode things, none of that the guest would need to worry about. Any of the interaction with the device is handled by CP, right? And so shared file system, there's a few other products or applications out there that exploit block IO, that capability there. Star Ident is sort of one of those one-off system services. This is a case where we want to identify a resource to the system, and we're going to use Star Ident to tell CP, hey, I'm a resource here, or in some cases a gateway to other resources, right? And so we'll see later on, not this week, but in some future weeks, things like how Performance Toolkit identifies itself as a resource and therefore allows people to connect to it through that. So those of you that are IO-centric or device-centric, you might have heard of ARIP, right? So the way that we get hardware errors from devices and so forth and record that into the system. There's a few other things that can be done with it. And so if I want to get those type of records, right, I would get them through this Star Log Rec system service, right? And so that also gets used in something else, and hopefully that we'll cover from the 12 pillars, is some of the DR type things like GDPS. So there's some usage of that there. And then perhaps your favorite CP system service, the Star Monitor, which we'll spend more time on here, but again, that's what's going to generate those monitor or performance records in an architected fashion. But wait, there's more. There are two message-related system services, Star Message and Star Message All. Right? These are ways of getting response or command response return information from CP. So a different way of, in a sense, getting around doing screen scraping type things, because I can now programmatically get that information into my program, right? And so different ways that you can deal with this. Also allows for information in terms of messages, right? If you recall in the second level sessions that we did, the ability to send messages between virtual machines, right? So there are some people that have implemented server virtual machines with the way you get a request into it is you just send a message to it, right? And this would be a way to programmatically deal with that. Again, there are different utilities that are out there that under the covers use this, but that's how it's done. And then next we have a security related one. So star RPI, right, is what's used by different external security managers. So normally from an IBM perspective, that would be RACF. This really only comes into effect if you have an external security manager installed in the system, right? And so part of what we do from a hypervisor perspective is there are stub modules that the ZVM control program ships with, and those get replaced by these external security managers. And then another way the information gets passed between the control program and the security manager is through this API, this star RPI, right? And so that's one way, actually, when I look at performance data, we get information as to how busy these things are. If I see a whole lot of RPI calls, that's a hint that there's a lot of external security manager activity going on. So star SCLP is an interface for dealing with the API into the HMC or hardware management console. Again, that's not used very often, but that's there. Likewise, star SPL for star spool. A lot of that was used and based on when we had advanced function printers, or there was heavy use of advanced function or what we call AFP printers in the VM environment. So it was a different way to deal with spool activity rather than, remember I mentioned diagnose instructions was another way that we interact with the control program. It's not too common that we have AFPs out there today, but that capability is still there. Symptom records is something that we'll cover when we get to problem determination, kind of outside the scope of the 12 pillars. But it's a way to get some very basic information about problems that may have occurred on the system, right? And so at one time that was more commonly used to be able to keep track of that. Now, the fact that ZVM doesn't advent very often, knock wood, that's not used as often or as critical, and there's other ways of getting that information out of dumps and so forth. And then the last one listed here is actually the most recent system service added into the product, and it's called star VMEVENT. I think this may have gone in just prior, around the time of single system image and live guest relocation. So star VMEVENT is kind of an important interface when we talk about systems management. And so we'll spend a little bit of time here going into a little bit more detail on that one as well as the two data generated ones that are there. Okay? All right, so let's start with star account. Now, one of the challenges with some of these things is parts of them are documented, as I said, in the programming services book, but that's if you really actually want to code to these things. If you want to use them, there's not a lot written there. It's usually elsewhere. So in this case, in the planning and admin book, in chapter 8, there's a large amount of information on setting up virtual machines for accounts, for ERIP. I believe the symptom is there as well. And in fact, there's a sample virtual machine that we ship with called disk account or disk ACNT, which will get that. Now, in a system config file, there's a statement called system user IDs, right? And in there is where you assign what virtual machines would typically handle some of this type of activity. So let me take a little pause here to talk a little bit about accounting itself. If you think about the history and the heritage here, part of the value of ZVM at one point in time was really time sharing, or this ability to take a very expensive resource like a computer and be able to carve up and allow multiple people to use that. Now, when we think about how expensive they were at that time, doing cost recovery or being able to account for who was using what was very important. And so that's what drove this accounting system service. And we're going to see some subtle differences between accounting and the performance data as we go through here. But accounting is really there meant to be able to capture the resources used by different virtual machines, by different end users, and be able to recoup the cost. Now, also along the way, right, some of the accounting information was actually implemented prior to things like Star RPI. And so you'll also see a little bit of information that some people might say bleeds into the security realm. So you'll see things like journaling records that can be generated in terms of who's linking to what, things like T-disk usage, other things of that nature. Okay, so you also might recall that when we set up our second level systems, we didn't want to be bothered with some of this. So we used the recording command to turn off and purge any records that were generated. So when we go to set this up, the recording command is another thing that we want to have in play here. It's what we would use to turn on the collection of accounting records. Now, as you'll see, when those records actually get generated, it's dependent on other factors. But the sort of the big switch is controlled in that recording thing. You'll see most, if not all, the records I think are still any byte. That beckons back to the days of the punch cards and then being any characters. So that's there. Now, with these different types of information, there's sort of a handle or some nomenclature that goes with it. So for accounting records, you're going to hear reference to accounting record types. So type 1, type dog, etc. And so you'll see a different set of record types there. So the ones that we typically think about, especially in a chargeback environment, are going to be ones that are cut on a virtual machine basis, right? And so this is going to give me information about how much CPU time was used, how much the number of spool IOs, page reads, page writes, different things of that nature that occurred. Now, some of those records evolved over time. One of the things that I'll just mention briefly is the idea that they record processor time. Right. Now, some of you know, we support environments where you may have both general purpose processors and IFLs in the same VML part. And in some of the servers that we sell, those processors may run at different speeds. Right? IFLs always run at full speed. General purpose processors may be what we call subcapacity, or some people use the phrase kneecapped, which seems kind of harsh, but they run slower or essentially longer cycle time. Right? So what does a CPU second mean in those contexts, right? Because with a faster machine, I could get more instructions done in one CPU second than I can a slower one, right? So the accounting records were adjusted to deal with that. Likewise, you'll see listed here CPU capability changes. What that refers to is that there are some scenarios where, very rare occurrence, but if the machine would heat up too much, one of the ways that we would help is to slow the machine down. Right? So if we don't run it at high clock rate, it's not going to create as much heat, therefore it stays cooler, but we would want to make sure that we have a record of that. Right? So another accounting record that we can get is one that indicates the CPU capability change. Now, associated with these accounting records is something called an accounting number. So virtual machines can have an accounting number associated with it, or over time it can have different accounting numbers associated with it. So the idea in the past would be perhaps I had a virtual machine and maybe I was running some jobs for development. So I would change my accounting number to be a development accounting number so that all my CPU time associated with that accounting number would be tracked. And maybe I'm also doing some other things like customer debug or whatever. And so when I was doing that, I would change my accounting number to one that deals with that, right? And so that as these records were generated, they'd be associated with accounting numbers, and we could find a way to build back to the correct accounting code from that perspective. That's not as common anymore. However, I still have some customers that kind of use that. Maybe they're developers on one application or project, have one accounting number set up in the user directory, and are able to get that information. So as I said, you can change that with commands, tie that in there. Now, as I mentioned, you don't really need to worry about coding to this system service. We have some things that do that. Now, what we ship with the ZVM product is something called Retrieve. And Retrieve, you'll actually find, is used for not only accounting records, but for error up and also the symptom records as well. Now, Retrieve isn't all that intelligent. All it's basically doing is taking those records and putting them into a CMS file, just a flat file of those records, which we can then post-process later, either with program products or utilities that are part of the system as well. Right? And so if we play with this on our second level systems, that will probably be how we do that. Right? So depending on the type of accounting records, and remember these are type, is how the nomenclature we use to deal with that, it will be generated or triggered by different things. So for the type 1 that are associated with a virtual machine, that will be triggered by things that log off, right? So when a virtual machine logs off, well, we want to know how much CPU it consumed and how many other things it did during that session, right? What a lot of people would also do is set things up so where accounting records on a virtual machine basis were cut at the end of different shifts. One time it was common practice to charge more during prime time than off shift. And so we would want to have those records from that perspective. Right. Now, this is one of the spaces where it kind of differs from performance data. From an accounting perspective, we don't really care whether you use those 20 CPU seconds all at once or over the course of an hour or in some other fashion, right? And so we'll get a single record at log off. We're not necessarily cutting a record like we do in monitor every minute. And so there's a difference then in terms of the amount of overhead for these accounting records. Now, that being said, the implementation of many of the accounting records and the monitor records are slightly different. So accounting, since we were talking about dollars or currency, depending on where you're at, people were very nervous about being exact. And so many of the counters that find their way into accounting records use interlocking instructions. That is, if activity is happening on multiple processors at once, we're going to make sure that those instructions interlock so that as we're updating a counter, we're not missing a single thing. Many of the counters in monitor, if we're talking about 1 million IOs and I miss one, that's going to be okay. We still have very good capture ratios. We'll talk about that when we get into performance. But that's another subtle difference if you're looking at the code. Now, these days, I don't know that it matters that significantly, right? But that is one of the things that's still there. I mentioned retrieve. You can also use CMS pipelines. So a couple weeks ago when we covered that, I mentioned very briefly a stage called StarSys. There's also one called StarMon that's going to be unique to monitor. But StarSys allows you to connect to a number of the other system services in this. And so I do have some clients that have written their own accounting package based off of pipelines. And so they simply connect into the accounting system service, and those accounting records come flowing into the pipeline, to which they process that and deal with them in different ways. And that way they get exactly what they want to get out of those records. Now, there is a utility that we ship with the ZVM product called Accounts. And it's fairly rudimentary. It's mostly focused on, as I said, the user records, the type 1 records. But it does take into account some of the different things we've talked about already and the accounting codes and so forth, and creates a simple, human-readable report. Now, there are other products that can be used. So the IBM Tivoli Usage and Accounting, it's either Monitor or Metrics. I can't remember what, that product. So ITUAM is a product from IBM that will process accounting records. Now, what's kind of nice about that is it will also accept records from Linux. So Linux has its own accounting records and other platforms and so forth. So that's there. Also, the vendors that have different solutions, but one of the more common ones from accounting is VM Accounts. So that's VM:account from Broadcom, formerly Computer Associates. Has a very robust product that allows you to carve up this data in all sorts of different ways in terms of doing chargeback and billing from that perspective. So there's probably some others that I don't recall right now, but those are the key usages of that. All right, so the other one I talk a little bit about is Star VMEVENT. And this allows a program or application to get notified when key events happen in the system. Right, and these can be anything from a virtual machine logging on or logging off. Or obviously, if I'm going to be using or have a program to monitor that a virtual machine is running, perhaps, right? Well, if someone relocates the machine off of the system I'm running on, I probably want to know about that because I don't really have to worry about whether it's running or not because it's running somewhere else. Or maybe I do need to worry about it, but I need to worry about it on a different system. Also things like, am I part of a cluster, and is my member going down, right? Or am I just started to come up and I'm joining into a cluster, or is there somebody else joining into this cluster? Maybe if there is somebody joining, I need to start talking to my counterpart on the other part of the system and deal with that. And so there's going to be all these types of information that an application can get through star VMEVENT. Right now, unlike accounts where it's referenced by a record type, star VMEVENT breaks their information down by class and then type. So class is the higher level breakdown of this, and then type is the particular type of record inside that class. And so, Operations Manager for ZVM is an IBM product that uses this heavily. And this is fairly important because we want to be able to react right away when certain things happen, right? And so there are star VMEVENT things that will be generated, say a virtual machine goes into a enabled wait, right? Well, if that's one of my TCP/IP servers or maybe one of my SMAPI servers or something, I want to know about that. Maybe I'm Operations Manager and I'm set up to make sure that these servers are running. And so if I see something like that, I want to report it to someone, but then also restart things. Now, I'm not covering the systems management APIs here. That's another way of interacting with the system and so forth, right? And it is run or set up via a number of system service virtual machines or server virtual machines. And there are products like IBM Wave that leverage the systems management APIs, right? So one of the things when we talk about systems management in general, we want to make sure that the thing that's running the system doesn't have dependencies on things of the system that it's making sure is running. So that's why Operations Manager isn't dependent on systems management APIs. Because if they were down, then Operations Manager wouldn't be running, and then it couldn't make sure that they're running, right? So some different approaches from that perspective. Also, we use star VMEVENT for things that we want to get notified of right away, and we don't want to do the silly games of polling, right? So we don't want to annoy a virtual machine by waking it up to see if it's running. Because then you get into the question, well, how often do you do that? Well, this is a very important virtual machine, so I'm going to do that every second, right? Well, then you end up wasting resources doing all of that, right? So star VMEVENT is one of those important things that allows us to efficiently manage these things, all right? Okay, so I want to talk a little bit about star monitor and just how performance data is used there in the time we have left here. So star monitor is another system service, though as you're going to see, it's a little bit different, right? So we talked about the socket interface. So when I look at star accounts, I connect, if I'm an application like retrieve, I connect to the system service, and then as accounting records are generated, they're sent across that IUCV socket type interface, right? So it's sending me that data. Now, we mentioned accounting records. The volume of that is fairly low, and it's fairly infrequent, right? With monitor records, it's kind of the opposite. So by default, we're going to generate a bunch of records every minute when the sample interval expires, and we're creating these records typically for every single virtual machine on the system and every single device. And so that's going to be a lot more data. So as you're going to see, with Star Monitor, we get clever, right? And so instead of sending the actual records across that IUCV interface, we put them in shared memory. So if you remember way back to Virtualization Basics, we talked very briefly about the concept of DCSSs, or discontiguous save segments. So this is the ability to share memory or share a segment of memory between virtual machines. So another trivia question is, what DCSS gets shared between not just virtual machines, but between a virtual machine and the control program itself, right? Well, that would be the monitor DCSS, or what most people refer to as mod DCSS as the name of that. So when you install ZVM, if you use the official install process, you're going to have a mod DCSS segment created for that. And it's one that, again, is going to be defined a little bit differently because it's writable by CP. I have a couple URLs listed there that just give you some background in terms of how to set those things up. Also recall that there's sort of two aspects of this monitor system service. There's the one side of it of an application connecting to Star Monitor, right, and being in communication with VM. But then as you're going to see, there's also a set of commands that actually start the collection of data. Now, while with accounting data, and to a lesser extent star VMEVENT, you typically don't have multiple people connecting to it and getting those records. Really, there's typically only just one thing that's processing accounting records. That's not always the case with star monitor. I might be running multiple things. I might be running, as you'll see, the MonRate utility just to capture and preserve the data. I might also be running Performance Toolkit. I may also be running something called VMRM, or VM Resource Manager. All those things connect to this monitor system service. And that was another reason for using the DCSS, is if I have multiple people connected, I don't have to send the data 3 times. I put the data in shared memory, and I just send pointers 3 times to the 3 different people that are connected, as we'll see. All right. So remember that we sort of have this connection to the star monitor, but then we also have to start and define our domains and so forth. Now, unlike the other types of system services we talked about, there are hundreds of different records for monitor, right? And as you'll see, they're going to be broken down into what we call domains and records. I typically talk about 3 flavors or 3 categories of monitor records, right? And there's some that are a little bit of hybrids between these. But those are configuration records. So these are things that don't change or very seldom change in the system, right? Like, it would be good to know what the name of this system is. So there's a configuration record that tells me what the name of the system is, whether it's part of a cluster, if it is, what the member name is, things of that nature. That's not going to change, so I only need to get that information once. So it comes out as a configuration record. Now, there are some things that originally were in configuration records, which over time we added the capability to change, right? So the amount of memory was in a configuration record, and then around 2008 or whatever it was, we added the capability to dynamically change how much real memory a ZVM system had, right? So that now also comes out in other records when that changes dynamically. And so while most of the configuration records you're going to get when you initially connect to Star Monitor System Service, there are some that are going to come out at other times. Okay, and then another category is what we call sample records. So these are things that we go around, and it's settable, but by default, every minute, VM's going to go around and sample different information and include that in records. So what you're going to see is some records are kind of categorized as configuration records. A lot of them are categorized as sample records. So I may sample my virtual machines. So I'm going to know what the Bittner user ID is doing every minute, right? Every minute, VM's going to go around and capture this data and write it out in there. Now, also within there, there's some data that we call high-frequency sample information. And that's the idea that by default, every 2 seconds, we're going to go out and see, well, what is that Bittner virtual machine doing, right? Is it waiting for paging? Is it waiting for I/O? Is it running? Is it idle? And by keeping track of those samples, we kind of get an impression of what does Bittner do, right? Or at least what does his virtual machine do? And so while we capture that information in control blocks in the hypervisor every 2 seconds, we only write it out every minute or whatever the sample interval is, right? So we can get good information, but keep the overhead low. Now, for both that sample interval, which is associated with how often do we write out the sample records, and the sample rate, which is how frequently do we do that high-frequency sampling, those are settable options, right? I usually say stick with the 1 minute. I usually take the high frequency down to 1 second. Now, that will be a factor then as to how much data is generated. So I do have some folks that say, well, I don't want that much data. I'm going to bump the sample interval up to 5 minutes. That way I get 1/5 the amount of data, or roughly 1/5 the amount of data. Now, that also sort of makes the assumption of, I'm not going to worry about any performance problem that comes and goes within a minute. My granularity now is going to be raised up to that 5-minute interval. I know some scenarios where we go as high as 15. I think that's a little bit high. After that, we start to run the risk of some counters wrapping more than once, right, in an interval, which makes it difficult for problem determination. Okay. And then the last category here is events. So a virtual machine logs on or logs off. I vary off a processor from the system. Those are all things you kind of want to know about if you're going to be looking at performance, right? And so those records will, again, be written when they occur to the system. Now, we have multiple ways that we can control how much and the type of data that gets captured. So we're going to have domains and then records within the domain. So domains can be enabled or disabled dynamically. And for each of those, we break them down between sample and event. So in the user domain, I may want the sample information, but perhaps not the event information, because that's a little bit more overhead, right? I may say that, well, these virtual machines are very important. I'm going to get information on those. These other ones, not so much. I don't have to include those. I know Bittner is a very good guy. He's not going to do anything bad, so I'm not going to collect data, right? So I disable the sample data for the user ID Bittner there. Or maybe I'm not worried about tape performance. I don't use the tapes that often. I can disable that, things of that nature. Now, the one thing I recommend here is some people will configure their systems as to being able to see all the devices on the floor, right? Well, if I see all the devices on the floor and I go with all the defaults, Monitor is going to collect data for all those devices, right? And you probably don't want that, especially like if you've genned in 2,000 3270 devices just in case. Getting a whole bunch of records that all have zeros in them, you probably don't need that. So in cases like that, I will typically disable everything and then just enable the things that are important to me. Okay, this is kind of the layout. Here are all the different domains that are out there. And you see which ones have event data, which ones have sample, and which ones have high frequency. Once you enable Monitor or start Monitor, you always get domain 0 and 1, so system and Monitor, those domains you can't turn off, right? And that makes it easier for the reduction programs and so forth because they can always count on having that information. And some of that information is important, right? So in the Monitor domain, we're going to find out things like, well, what time zone are we in, right? Because when we look at performance data, I want to be able to see what time things happened and actually know that based on current time, okay? And Apple Data is kind of a special domain. That's a domain that allows virtual machines to contribute their own data into the system, right? So what you kind of see here is kind of this construct of I have a data collector machine there. It's going to be talking to Star Monitor, but it has loaded inside its virtual machine that mon DCSS where the records are going to be set. So as Monitor generates records, they're going to be written into that DCSS. Monitor through the IUCV interface is going to say, hey, wake up. I just wrote some data, and it'll say whether it's sample data or event data, you know, depending on where it's written in that DCSS. Go process it, right? So my utility or whatever that I've written there is going to process that data, and at some point it's going to go back to Monitor and say, hey, all right, I'm all done with that data. That allows Monitor to know that, okay, I can freely reuse that space and continues to process along this way. Now, again, remember, I'm only illustrating one virtual machine here, but I could have multiple virtual machines. That DCSS, that shared memory, is the same across all of them. And so the Star Monitor System Service is going to be expecting to hear back from all of those. Now, you can set up Monitor so that if you have an application that can't deal with that, you can get exclusive use, right? Which means you can't share the DCSS then, right? Now, one of the things to bear in mind here is your application dealing with this data has to be fairly efficient, because if I'm writing sample data in there every minute and I haven't gone back to Monitor to say, yep, I'm all done with that data, there's a problem, right? Because if both John and I are processing this data in our applications, I might be slow, John's ahead of the game here. Monitor's going to say, Bill, we're sorry, you're out of luck. I have new data. I've run out of space in the DCSS. I have to reuse that, so I'm going to do that, right? And so I would get a special communication back that says, you know what, I'm purging that data that was there. You need to get over it, right? Okay. So one of the utilities we ship with ZVM is called MonWrite. Started out as a sample, but has sort of become the de facto standard for some of this. And it's just another dumb little utility that takes the data and writes it out to a CMS file. Now, at one time, it was more common to have this write to tape. It's been a long, long time since I've gotten a tape with MonWrite information, right? But that capability is still there. So pretty straightforward, just creates a CMS file with that. It has had some new options added to it. By new, I mean like within the past 10 years, to where there's an exit to it, right? So what we'll typically do is set monWrite up to use the close option, and so you can set it up to say, every hour on the hour, close that file. Maybe I call something to delete the oldest file that I have on the disk so I don't fill up the disk, things of that nature. Right? Okay, so I'll talk to you a little bit about the monitor system service. Wanted to look a little bit at how things are run. So we have my system service here, right? And we're going to have things like Performance Toolkit or monWrite or VMRM, which are talking to the system service, right? And there's going to be different things that cause data to be written into the DCSS by the system service. And all of them are also connected to that. Now, monWrite we talked about is just going to generate that raw monWrite file, which either Performance Toolkit can post-process in batch mode, or Performance Toolkit could be doing this in real time and putting out information, in which case it can create history files that we can post-process later on, or look at it through a 3270. For those of you that are more browser-based, there's a browser interface to that as well. Now, Performance Toolkit can also be set up to have yet another DCSS, this DCSS SegOut here, which it's actually going to share with another virtual machine for the OMEGAMON product. So remember, Performance Toolkit is a feature of ZVM, so when you install ZVM, you've installed the code for that as well, but you have to enable it. And so Performance Toolkit is going to do some of the heavy lifting here. It's going to do some of the number crunching, and it's going to write some of its information out to shared memory here, which we'll see in a second that an agent here, this IRA, Intelligent Resource Agent, I don't know, I can't remember what the IRA stands for, is part of the OMEGAMON XE product, right? And that's running in a Linux virtual machine. So it's going to take this information and push it out through the OMEGAMON suite of servers. So it's kind of cool that we have a Linux virtual machine and a CMS virtual machine sharing memory and talking to each other through that interface, right? And then we can get all sorts of things through the OMEGAMON product and so forth. But in both cases, in all these cases, it starts with things happening in the control program and going out through the VM Star Monitor System service. Now, I mentioned SMAPI earlier. This chart got a little crowded here, but I should also add in pipelines, right? So pipelines can connect into this, as well as the Systems Management API has a way of talking to a Performance Toolkit server or virtual machine and pulling a subset of information out of that, right? monWrite is going to take all the records and write them out. Performance Toolkit is going to take a subset of the records and do things with it. A subset of that information OMEGAMON is going to take and deal with that, right? So when we think about what we're trying to do and what kind of data we need, look at all those things, right? And so again, remember, if my intervals for when I'm doing monitor records, that granularity, the granularity Performance Toolkit, which is going to affect the granularity of the OMEGAMON things, right? And so all these things come into play in this whole food chain of information here, right? All right, application data. And so this is a way for a virtual machine to pass data into the monitor data stream. It's set up via a diagnose called diagnose dog Charlie, right? And it's basically a way of telling VM, hey, I have some performance data in my virtual machine. When you collect that other sample stuff, would you mind getting my data as well, right? And so, the TCP/IP stack uses that, shared file system uses it, Linux will use it, VMRM itself, the VM Resource Manager does that, and so forth, okay? And so kind of how it works is I have an application here that's going to do that diagnose dog Charlie, and either to say that this is an event record or this is sample data, right? And so whenever we collect our sample data, we're also going to grab a copy of that and put that out in that data stream, right? Or in the DCSS. Now, what's really cool about that is there's very, very low overhead there, right? Now, other approaches to this might be going into SNMP or TCP/IP into this, say this is a Linux guest over here. Well, if I'm going to get information from that via SNMP, that means that virtual machine has to run. That means it has to wake up, right? So how many of you have heard from somebody once in your life, hey, are you awake when you weren't awake, right? Not really a pleasant experience. So we can do this now. The level of detail is a lot less, right? So for the Linux records, for example, I might get one record that talks about CPU information, right? So I'm not going to get individual processes through this, but it might be enough information to say, hey, there's a lot going on in that virtual machine. A lot of it's in the user space. Maybe I should log on to that and see what's going on with that Linux guest that seems to be causing problems here. All right. So just a cool little thing we need to be aware of. Okay. All right, performance toolkits. Again, we'll spend another session on this, so I'm going to go kind of quick over this. Most of us know it from a real-time processing perspective, but like our performance folks here, they use it an awful lot in batch mode, right? We'll talk about how we post-process the bond rate data there. You can also do some capacity planning and processing the historical records from this, and there's some ways to do some central monitoring for that as well. There's some exceptions, there's some other processing and so forth that in a later session we'll go into a little bit more detail, but really the bread and butter of Performance Toolkit is the real-time and the batch mode processing, and also that aspect of passing data on to OMEGAMON. But again, Performance Toolkit, the green screen, kind of getting you to that. Lots of different information there that's available. Now again, remember, since we have the option of enabling and disabling the types of data that we get, Performance Toolkit can't always report on everything, right? So the things you see highlighted in white here, those are records or reports that PerfKit has the data to report on, right? Some of the things that are greened out, like the Linux systems here, we're not getting those Apple data records on this system, and therefore I'm not going to be able to report on that, okay? And just another sample there. So again, down here in our VM system, I might have the monitor system service kind of running here, Performance Toolkit's picking that up. There are extensions for OMEGAMON that are actually part of Performance Toolkit or run as part of Performance Toolkit that are writing the data into the DCSS. I have this little agent, special VM agent, that runs in a Linux virtual machine that the customer sets up. That's going to take data and pass it on through something called TEMS, Tivoli Enterprise Management Services, I believe it is. I also can have agents that run in all my Linux guests that are collecting Linux data, right? So if you're familiar with SAR information, it's things of that nature. That all flows into this TEMS, which then interacts with a Tivoli data warehouse, right? So where we're going to store or save all this information. TEPS is kind of a processing perspective, Tivoli Enterprise Portal Server, I believe is what that stands for. And then the TEP is actually the portal or browser front end to all this. And so I can look at historic information by pulling it from the warehouse, and then also information flows out real time on this. So OMEGAMON XE is the one that gives you the wow graphics and so forth. So you see different things here in terms of paging and spooling, different volumes that are here, information of that. So you can see in different graph formats. There's also for NASCAR fans, you can get the dials here, which are kind of important. You'll see color-coded highlights in terms of setting thresholds for yellow and red, things of that nature, right? And then the other valuable thing from an OMEGAMON XE perspective is there's an agent for pretty much everything, right? So if I'm running DB2 on ZOS, there's an agent for that. DB2 on Linux, there's an agent for that. And it all has the same look and feel. So when we talk about integrated, it's integrated from that look and feel, and to some degree the ability to make combinations of that information. Because very few times do I have an application that runs solely on ZVM on a Linux guest. It might be spread across multiple systems. It might incorporate ZOS as well in that, right? So that's all there. Also some things, some expert advice and ways to react to different thresholds and monitoring capability that are there. So I know I went over a little bit there, but hopefully that gave you a little bit of feel for really where that data comes from and that why those system services are important and how they flow up through all of that. All right. Okay, folks. Have a good week. Talk to you next week.
Thanks for watching. If you enjoyed this video, don't forget to like and subscribe to see more videos like this one. Have a suggestion for another video topic? Feel free to leave a comment below.